Good day everyone. For today, I'm going to be showing you how to solve a vector addition and component method. So, for us to understand it more, let us have a sample question to answer. So, grab your pen, paper, and your calculator. The question that we are going to answer is finding the resultant vector. Before we can find the resultant vector, we must have a given magnitude. So I use my name, my favorite music, and my age, and put some units to make it as a magnitude. I must also have directions as a given. So I use my height, my birth month, and the first letter of my crush's name. So I put some directions and the degrees. So now we have the complete set of the vectors so that we can add it all up. This is the first vector, second vector, and the third vector. So now we have the given, we must draw it in the Cartesian plane. So before that, let me tell you that it should be y of x. This is our Cartesian plane. This is the y-axis and the x-axis. So now we must put our given to the Cartesian plane. Our first direction is 60 degrees north of west. So we must locate the north and the west. So our degree should be in here. 60 degrees. Is 11 meters per second. Length of our first vector, it should be like this. So let us label 11 meters per second and 60 degrees. And now I am done putting the second and third vector into our Cartesian plane. For that, we must find the angles of our vectors. So what we should do is that we should always start from 0 degrees, that is in here, going like this or going like circles. So 0 degrees going here. The 2 quadrants is equal to 180 degrees. So here going to here. So 180 minus 60 degrees is equals to, the answer is 120 degrees. So we must repeat the process for our second vector and our third vector. So these are the answers for our angles. After those hardships, we'll now tabulate or make a table. So these are our magnitudes and these are our angles. And now you see there are something missing in our table, and that is the x and the y's of our vectors. So in getting the x, we must use the magnitude cos the angle. So in getting the x of our first vector, we should use 11 cos 120 or magnitude cos the angle equals to negative 5.5. The process is just the same for our second and third vector. Now we'll be getting the y's of our vectors. So what we will use is that magnitude sin the angle. So our first vector should be 11 sin 120. In getting the y of our vectors, we must use magnitude sin the angle. So example, the magnitude of my first vector is 11 and the angle is 120 degrees. Let us use our calculator. 11 sin the 120 degrees is equals to 9.52 6279442 or 9.53. I just used the same process for a second and third vectors. After it, we must add all the x and all the y. And the answer of our x is negative 17.47. Already add up our y's and the answer is 7.99. Let us label this our A and our B. because we will use this for our next. Finally, we're in our last step. Now we can really find the resultant. So r is equals to square root of a squared plus b squared. Our a is negative 17.47 and our b is 7.99. And now I already substituted it and add it all up. And the answer is 19.21. And of course, do not forget the unit. My unit is meters per second. Now, let us find the angle. So, what we should use is tan theta is equals to y over x. But we are just looking for that angle. We must move the tan in here, turn it to arctan. So what we should use is theta is equals to arctan times y over x. So our y is the 7.99 and our x is negative 17.47. Now we must substitute it from this. So we substitute it like this and then use the calculator and the answer should be negative 24.58. It should be absolute, so it is 24.58 degrees. And it should be N of E or north of east. It's because of the component in here. So the x is negative 17.47. The y is 7.99. So it's a positive, so the y should be in north. And the x is negative, so it should be in the east. And the final answer should be 19.21 meter per second and 24.58 degrees north of east.